Hello and welcome. Hello and welcome everyone. This is Aaron van Ammers, CTO and founding partner of Outlier Ventures, and with me is Pedro Gomes, founder and lead developer, I guess you called yourself, of WalletConnect. WalletConnect is a protocol, one of the non-tokenized kind, to connect different decentralized applications, different DApps, with different wallets. And yeah, as you might know, wallets are a really important part of enabling access to decentralized applications that live on a blockchain or partially off a blockchain. I'm really excited to see what WalletConnect makes possible to enable user onboarding in a very frictionless, friction-free manner. We'll go into we'll show something. We'll show it working. I've seen it working, so it must be working when we show it now, but the demo effect is always strong, so let's see. As I posted on Twitter, I'm not going to sign any transactions on these gas prices because that's not going to work. We can at least show you the pop-up that, hey, here it is. This is where you would sign.
I have some funds on Gorley prepared, so.
Oh, well, there you go. There you go. Yeah, no, that's good. All right, great. So I'll just start off with a few small slides. If this would please grow in size, or what? Let's do that. So there we go. Just a quick disclaimer. Nothing of this is investment advice, even though I don't suspect we will be mentioning many tokens or things of value, but always good to know. Just a very brief history for why would you need something like WalletConnect? Where did it come from? And accessing DApps, how did that work and how does it work? So in the very beginning, there was Mist. Mist was the very first browser for Ethereum, and it wrapped the very first Ethereum blockchain node. To be able to access any decentralized applications, everyone would need to download the full blockchain data and be a node in the network. Let's say their computers would be a node in the network, which is great in principle because then you get a huge peer-to-peer network, much replication of the blockchain itself. But first there is friction because you need to download this big application that takes a lot of time to sync. And as the blockchain grew, that became quickly quite impossible for people to onboard. Besides the fact that building an entirely different browser was quite a difficult task in itself. So that didn't quite fly for giving many users access to DApps. What did fly to a good extent was MetaMask, which is a browser extension for Chrome browsers and possibly others. But basically, you can use your normal Chrome-based browser, or Brave browser, which have now actually integrated MetaMask or forked the code as Brave crypto wallets, and use your regular browser that does all the things that's to access websites. But through this extension, you're able to access DApps and blockchain infrastructure, like querying the blockchain, submitting transactions on your normal browser. So MetaMask is very widely used, but still there's quite some friction because it doesn't always work optimally. You only have a single option to use. If you're using in-browser keys and your seed phrase, that's might not be very secure. People might not handle that very securely. So it's great, but it has drawbacks too. Over the years, we've seen some more diversity emerge in many types of wallets with similar approaches, which also either use a browser extension or use some other way of the DApp interfacing with their infrastructure. But always, it would be a specific option. So when you have used any DApps on Ethereum, you're probably used to seeing these kinds of interfaces pop up when you say connect to wallet. So you can either use MetaMask, you can use Fortmatic, you can use Portis, and these lists have become longer and longer. and on other chains as well, you've seen similar wallets appear. So there's for Cosmos, the Cosmos ecosystem, there's Kepler wallet, and there's some others. For the Tezos ecosystem, there's some others. So, and they all have different browser extensions. Now, initially with the Ethereum ecosystem, and I'm eager to hear what about your plans or current developments towards multi-chain support, but let's stick to the Ethereum ecosystem for now. There's this option that you might also have seen, which is WalletConnect. And what WalletConnect enables you to do is connect any wallet to any Dapp, or at least any supported wallet, but there's a significant number, I think over 50 wallets now, to Dapps that support it. By initially scanning a QR code, and then your the Dapp talking to wherever that wallet is, be it on your phone or be it on another desktop, to say, okay, now I would like to access some data from the blockchain, or now, dear user, I would like you to sign this transaction because you requested so, and there's something to sign, and that allows access to the wallets that people want to use and that they already have, and without any or very little onboarding friction to use many Dapps. So yeah, very happy to have you here today, Pedro. You said you're able to demo WalletConnect yourself. I've set things up so that I might as well. So let's see where we get to. I have it with the actual mobile and website and desktop setup, but yeah, let's see where we go. I'll hand screen sharing to you, and we can go from there.
Great. Thanks for explaining what I've been explaining for a lot of years. It's glad to see that this history is very well known now, and people understand the value of a WalletConnect protocol and how this evolution of a Web3 experience has come and where it could go potentially. Yeah, I would like to do the demo myself. I've done it quite a few times, and I also would like to both make the differentiation between WalletConnect v1 and v2. Since v2 is currently in alpha development, and I think that many people haven't seen it yet. I had open here WalletConnect, but as Aaron has already given a very good presentation, a few things to point was that WalletConnect started first, as it describes on the website, to allow mobile wallets to connect to web applications. And fortunately, over the last 3 years, it has grown beyond that. We connect mobile wallets to web applications on desktop, on mobile, and we even connect desktop applications to web applications on desktop, and also mobile native applications to mobile native wallets. And it has really grown as an ecosystem. We have over 55 wallets currently available. It has grown a lot, and I think that something that WalletConnect really tries to achieve is try to reduce the fragmentation, where instead of us developing proprietary solutions, we actually can all share an open protocol that will serve the most people as possible, so that people can deliver specialized experiences based on their user bases and still share the interoperability benefits of an open protocol. And that has definitely caught on with applications as well. We've grown past the 100 applications now. It's a ever-growing ecosystem, and I'm very happy that it has succeeded at gaining this level of adoption. So getting into the actual live demo, this is something that I've been displaying for a lot of years. In the beginning, I had this kind of chicken and egg situation where I had to explain to wallets the benefits from an app and the app from the benefits of a wallet, and how the two could actually share this protocol. So I had this little demo with me always that allowed to exemplify on the left with the white background, an application, and with the dark background, a wallet. You would go to an application and you would connect, and you would be prompted with a QR code. We even have this copy to clipboard capability that allows you to go into another desktop application instead of you having to scan a QR code. And when you paste the QR code, you're able to connect to the server, and you'll get prompted with the exact URL from the application, which identifies this application is as access for you. So you're able to approve and reject. And at this point, we're actually going to open the gateways for the application to ask for information. We're not only exposing the network that we're connected to, but we're also exposing the accounts. And for example, a lot that the WalletConnect has built, as Aaron explained, was on top of what MetaMask has built, just like MetaMask has built on top of Mist. So a lot of patterns have kind of like been created in terms of how wallet controls the accounts that are active and how the networks change. And we kind of demonstrate this very nicely here, where you can switch a network. For example, let's testnet with Goerli, and I switch it on the wallet side, and it reflects on the application immediately. And you can see that I do have some balance here, so we can actually have a demonstration of transaction. You can see here there's three main actions on Ethereum that we use today. There's the send transaction, there's the personal sign for a message, and there's even the type data, which is a more structured data structure for better typing on messages. We can do a transaction here, and while it's pending, we can see that pop up on the wallet. And this allows us to actually have very securely the ability to remotely sign something on the wallet on a completely different environment without having to expose the private keys. So the two devices are connected through an end-to-end encrypted communication, and we just get what it's called the signing request, and we can tell that this application wants to send from this account to this account with this amount, and we can have this authentication process happen informed by the user on its wallet of choice, and then provide a signature or a result to this action from the wallet. At this point, we approve and we send a transaction on chain, and we send it back, and the application is able to confirm that this transaction has actually been successfully made. This can expand beyond transactions, even though WalletConnect is mostly about blockchain, it's focused. But there's a lot in Web3 that can be done with just signing, something as just proving that you own this account with a message where it says, this is my email, signed at this timestamp, let's approve. And at this point, I prove the ownership of this account, and I can verify that this is the valid account that's signed with this signature. It's something that we've grown used to in the Web3 world, but I can actually see this growing a lot of use cases beyond the current blockchain that we have. And this is what V1 looks like. And you may think, like, how can we actually expand beyond this? What are the missing pieces within the existing protocol that exist? First, definitely the idea of having to scan a QR code more than once. When I disconnect here, you're needing to pair the two devices all the time. So for each new session, you need to create a pairing. So on the version 2 of the protocol, we actually decoupled these two concepts altogether, and you will only need to do this pairing once. So you will have a long-lived pairing that will allow to instantiate or propose new sessions every time without having the need to scan the QR code or do a copy to clipboard or a deep linking. And that's what really makes V2 very critical for improving the user experience, but also the ability to have multiple networks at once. So the idea with V2 is that we want to break some patterns that have been created in the past with Ethereum applications, where we have this idea of a single account and a single chain active at once. And I try to demonstrate here in this example where we have an application that will determine which chains it wants to use from the wallet. And then it has a multi-chain wallet that has some accounts available to it. So for example, here we have Ethereum, Goerli, Optimistic, Cove, and Matic, Mumbai, and everything. And we can even switch between test networks and main networks here, but let's keep it to test nets. I have funded 2 accounts on Goerli and Arbitrum Coven. And the key feature here is that prior, we would have to switch network, as we saw in the previous example, about we're connected right now on mainnet, and now we're going to switch on Goerli, and the application would have to actually comply to this switch in order to maintain this active connection. With V2, what am I going to be able is actually choose, okay, for this application, I might want to do a cross-chain swap. So I'm going to connect to both Goerli and Coven, which is the the chains that I'm going to swap assets between, and I'm going to propose this connection with the wallet. So we do just like with V1. And what we can actually see here is, once again, we have an understanding of what application is actually requesting this set of permissions. And we have an explicit consent from the user to actually connect to these chains in parallel. It says, we want to connect to Goerli and we want to connect to Arbitrum. And these are the methods that we're actually going to be using for this session. This allows us to have a much better understanding of the compatibility between applications and wallets that will allow us to not just stick to Ethereum light chains, which are based on the EVM, but also allows us to support something like Polkadot and Cosmos, where the application requests a set of chains and a set of methods that it's going to use, and the wallet will be able to either comply with them and be compatible with the session or not. In this case, we are compatible, so we're able as a user to approve, and we can immediately see that reflect on the, oh, actually, and it didn't go well. Maybe I took too long while I was explaining. There's a 30-second timeout, and oh no, and there we go. So we have on the application the two accounts connected, and we can see the wallet doesn't have an idea of active accounts. It actually has the 4 active accounts as we had previously, but the application is only actually accessing 2 accounts that we actually expose. We can actually see one session active here, and we can actually explore the accounts that we expose to them. We have these 2 accounts, and that's the only context that this application has. And now, something that is very different from current Ethereum applications as well is that since we have parallel accounts, we also have to an understanding that, like, every time we request something to sign, that we need a context about this sign. So if I want to send a transaction for Arbitrum, we're going to receive this on the wallet side, and we can see a transaction. And previously in V1, we had an assumption of an active chain, but in this case, we actually have, okay, example app wants to sign something for Arbitrum, and we have this context very clearly when we actually sign a transaction. So we're going to approve this, and it's going to reflect on this side, and we can see that it has been successful. On Goerli, we can do the same thing because it's part of the set of permissions, and we can see that the transaction is actually presented with the target chain for this transaction. And these are simple patterns that kind of allow multi-applications to be improved. For example, one that might be more common to a lot of people is when you want to go from Ethereum mainnet to XDAI, you actually have to do a transfer into the escrow contract, and then you have to do a claim on the other side of the bridge when you want to retrieve your funds on the XDAI side. And the current pattern is that you would switch the network on MetaMask in order to have this ability to send a transaction on mainnet and then claim it on XDAI. In here, we would have the ability, as you could see, to send transactions in parallel for the chains that were permitted on the initial of the session. So V2 is not only just chain agnostic, which allows any APIs to be compatible, but it also allows parallel chains to be active within the same session. This is something that is currently in alpha development. We're really close into getting this into a public beta. And the last thing that we're really working on is actually on inter-relay communication. If we go to the documentation on V1, we actually can see on the technical specification that it describes that there is this concept of a bridge server in the middle of the communication for V1, but we want to make sure that on V2, we remove this requirement that both applications need to talk to the same server. So we want to introduce inter-relay communication. We call the new servers relays because they actually just broadcast these messages between the network, and they can actually depend on independent servers altogether. So I don't know if you would like to jump into more technical specification. This kind of rounds up like the V1 and V2 comparisons and where we are today.
Yeah, no, this is great. Yeah, a few directions to go from here. And first, what you said about multiple network supports and this changing networks thing is now a huge hurdle for people to use things like Polygon, previously Matic, and XDAI, because in some cases, well, most cases, will have to manually add that network in the first place, like go to some hidden setting, difficult things. For many users, that's difficult. And then indeed, even if you're technically very capable, you still get a friction of, okay, I go here, sign this, switch the network, sign this other thing. It becomes very lots of friction there. So you showed that looks awesome. And you mentioned it could offer support for Cosmos and Polkadot as well, and I can totally see that work, because increasingly you'll see these bridges appear. Like you mentioned XDAI and ETH, so that's EVM to EVM, but there's a secret network to Ethereum. There's Polkadot to Ethereum, like quite a few are implementing this chain safe bridge. And there you have, two different types of networks where you want actually, as close to or as smooth as an experience how you described it with XDAI. You just want to see, okay, these two networks want to connect, and actually they're different. So would it work like that? And what would people on the different network side, the non-Ethereum network side, need to do to make that work?
Well, from what I gathered in the last years, it all breaks down to JSON RPC communication, because that has become very popular, especially for Ethereum applications, because that was how MetaMask was able to basically break down from being Mist being an all-enclosed solution, had full access over the node. It was when we actually added this JSON RPC interface that we could remotely call methods from the browser extension that we expanded this user experience. So what I learned is that we could have done the same thing with a mobile wallet. So WalletConnect v1 basically just replicates the same pattern as a browser extension communicating to a website, but just through an encrypted channel over the network. So what I thought was, in terms of actual compatibility, we just have to have an understanding about which methods are required from the wallet to actually ensure a good user experience. For example, in this case, where we actually prompt the user to connect to the session, we actually determined that we're going to need to send transactions, sign personal messages, and sign type data. In the current world where WalletConnect v1 exists, we saw a lot of problems where, for example, wallets didn't support the type data signing, for example. And this would basically make this assumption that, oh, I connected to an Ethereum wallet, I should be able to do this. But because it's a draft spec, not everyone decided to put an experimental feature on their production wallet. So they would hit this problem where they say, oh, it doesn't work with this wallet. But here, at least we have an understanding up front on the session proposal that we are going to require this API. And if you match it, then we're able to connect to each other. Otherwise, we're just going to hit this problem eventually in the future. And I noticed that this was enough not only to meet the requirements of some applications using experimental APIs on Ethereum, but also to actually expand beyond Ethereum and just have an understanding. Okay, we're going to need some Cosmos sign. Oh, we're going to need Polkadot send transaction. And in expanding this idea of permissions that are beyond just an Ethereum API allows us to have an understanding whether this wallet can actually match the requirements for this session to go successfully for the user. And we actually did this, we started thinking about this idea of chain agnostic way before with the Chain Agnostic Standards, which is an organization on GitHub where we actually try to define standardization that is not biased to any blockchain ecosystem. And for me, one of the most important ones is actually the account ID, which is used by WalletConnect v2, where you can actually see that for each address, there's also a context about the chain ID, because it's quite inconvenient right now where you could be given an Ethereum address, but you actually don't know where that chain is. And this actually was, for example, a problem. Burner Wallet, which was a very popular adoption tool for like people to use XDAI, people would send a transaction on the Ethereum mainnet thinking that this address was on mainnet, but it was actually on XDAI, and this would complicate a lot. So having this understanding of for each address, you have a context of the chain, it's very important. But we didn't want to be biased to Ethereum, so we actually added what we call a namespace. And in this case, the namespace is how you actually define a chain ID on Ethereum, which is EIP 155. And we then have a reference to the actual namespace. So for example, Ethereum mainnet would be EIP 155 with the reference 1. And this would understand as Ethereum mainnet with this address. And the same thing happens with Bitcoin. We can use this BIP, which defines a namespace, which is the genesis hash for that actual blockchain. So we can have an understanding that this address matches on this chain to the account that we actually want. And this goes on with Cosmos and Polkadot. Kusama is an incentivized testnet on Polkadot. And we can actually have an understanding about the address and the chain. And this is how WalletConnect V2 basically builds on top of the idea that these chains are going to be fully heterogeneous, and we shouldn't make assumptions about how they derive accounts and which APIs they're going to actually use.
Yeah, and so here you define it on the address level, and you have this generic namespace, and different types of networks like Tezos, EOS, Cardano. They could do the same thing, define their namespaces and types of addresses. And I guess that then extends to the different functions that are supported and the parameters that they require. So for Ethereum, I presume you've defined those, but you want to make sure, like if like the Cosmos community wants to make sure that this works for Cosmos, for the Cosmos Hub, there needs to be a consensus. Okay, these are the methods. This is what they're called. And on the wallet end, you implement those, and on the Dapp end, you implement those.
Exactly, and basically it all goes through standardization, because from my learning with adoption on WalletConnect V1, I found myself not documenting so much on the WalletConnect side, but actually documenting through EIP standardization. So EIP standardization was a way to coordinate how applications and wallets would talk to each other through ERCs, and that allowed me to actually be more productive in actually building features, since we had a place where we could reach consensus about these interfaces. And CAIPs basically take this to another level where it's not just about Ethereum, it's about everything. So WalletConnect depends a lot on the CAIPs, which we actually been working way before WalletConnect V2 was even in alpha development. So there is references for different ecosystems, and we actually have how to actually do a provider handshake, where we actually saw that an application can request, okay, I want this chain and we want these set of methods, and then the wallet would respond, okay, so here is the account for the set of permissions that you requested. And from that point on, then the application has the ability to act within the scope requested.
Yeah, great. And so for the heterogeneous case of, say, Ethereum to Cosmos Hub, to connect a wallet to that, would that wallet then need to also support those two networks? Like, for example, Trust Wallet supports multiple networks, and other wallets do not. Would only a wallet that support those two networks be supported, or could you do like this request goes to that wallet and this request goes to the other?
So the idea, for example, with the CIP provided handshake, is that we have very explicit error codes where we have, for example, the user disapproved requested chains, or the user disapproved requested methods, or we have simply the requested chains are not supported, the requested methods are not supported. So we can have an understanding about where did this handshake actually fail, And should we adapt the set of permissions, or should we just notify the user, okay, we tried and we weren't able to connect to the wallet that you chose? Having this communication is very important because, for example, you could have two different strategies here. If your application requires specifically a method, let's say the type data on Ethereum, which is very popular problem, where you really need to sign with type data and the wallet returned requested methods are not supported, then you would be able to adjust, you would be able to reject and prompt the user to say, the wallet that you use does not support the signing that we require. Or you could have an application that, for example, downgrades that type data signing into a personal message signing and just compromises on a different type of signing in order to be compatible with the wallet and just switch to a different set of permissions.
Right. And so for the case of, I would be using a Cosmos to Ethereum bridge or Ethereum to Polkadot bridge, many wallets would then give the response, well, requested change are not supported because I only support one
exactly.
of the two.
Exactly.
But builders of those bridges could select a few wallets and say, well, these two wallets actually work pretty well with those two chains, so better use those, but still use WalletConnect to connect them. Which makes implementation much simpler on their end, because they still would only have to support the spec rather than specific integrations with one wallet or two wallets or three wallets.
Exactly. Like the point of the protocol is to be flexible enough for people to build the user experience that they're trying to achieve. And this could be a super decentralized that allows, for example, I want to connect in parallel two sessions to two different wallets. It will be a Cosmos wallet, and I just connected to two sessions in parallel with their own scopes defined, and I will be able to still have the same user experience. Or I could just require the users to use a multi-chain wallet that connects within one single session, and it needs to support both of these chains. It really is flexible to that point, and it's just a matter of designing the experience on top of the protocol, still maintaining the interoperability between a single chain wallet and a multi-chain wallet.
Yeah, great, understood. I want to learn more about the bridges in V1 and the relayers in V2. So let's start with V1. Like, what is the role of that bridge, and who operates it? So, and what extended to that, what's the security model of that?
Yeah, so as you can see from the technical specification on the documentation for V1, we can see that the bridge acts as an intermediary between the two. As a WebSocket server. That's essentially what it is. The messages are encrypted using the information in the QR code or the deep link, so that only the Dapp and the wallet would actually have access to the contents that are being relayed through the WebSocket server. Since it's encrypted, the messages could go through to the bridge, and the bridge would not have an understanding of what is actually in the payloads of the messages. So there isn't a security concern on that end, but of course there is the security concern of availability. In the V1 design, the wallet and the Dapp need to be connected to the same server. The Dapp is the actual one who selects the server, so it has become very popular to use the free bridge server that we run, and I believe there's only 3 applications who actually run their own servers, and the wallets would then connect to those servers. We want to change this with V2, where any server can be used and the servers will communicate between each other. This means that using the server is not an availability problem, because everyone will concern with its own server. Instead of having a single server between the two, the Dapp can connect to server A and wallet can connect to server B, and then server A and server B can talk to each other. And actually how we're looking to achieve this is using Waco network. So Waco is the protocol for messaging that evolved from Whisper, which was initially part of the spec of Ethereum, it has evolved into 6 versions. And eventually, the team that was developing decided that we can do much better. We just need to completely rewrite this from scratch and do a new version. And Waku was born from that. And Waku actually has a lot of properties that the bridge server has, because when I wrote the first version of WalletConnect, I actually intended to use Whisper, and the bridge server was supposed to be just a quick hack, a temporary hack. This temporary hack has been 3 years in the making, and I'm really happy to see that at least with WalletConnect V2, we're going to move on from the quick hack.
Yeah, I remember how MetaMask was also a temporary way to access DApps quickly. So yeah,
exactly.
That's history. Yeah. Yeah, but that makes sense. I wondered about that. Like, hey, you're actually doing something isn't there a decentralized protocol for that? And yes, there is. I mean, there's in the making. So yeah, Whisper indeed. The original approach I remember. It never quite got to fruition, but good to hear that that Waco picked that up. And it reminds me a bit, and there's the Reddit point then on how Gnosis Safe uses a relayer architecture. So they do not use Waco or anything like that, but they do use a relayer architecture. I guess their relayer architecture is a bit more similar to your current bridge model, where they operate a bridge or a relayer for you to relay your unsigned transactions or your partially signed transactions between your signatories of your multisig. But you can run your own, but not many people do. Whereas this relayer architecture is then a more open and decentralized model.
Yeah, I see that. Like, for example, I really like what Waco has evolved to, because it has completely decoupled with Whisper. Was meant to be used as part of an Ethereum node. You're running an Ethereum node and you enable Whisper. So there was this very tight relationship between what an Ethereum node and what the Whisper node was. And Waco, it's its own completely thing. It's independent. It focuses on decentralized messaging, and it actually has evolved, especially with the Waco version 2, into something that's incredibly modular, where we have 3 separate modules, which includes the relay, the store, and the filter. And the relay inside Waco, it looks exactly like the bridge server. So there seems to be no need for anything new or to reinvent the wheel when Waco has decoupled not only from the Ethereum node, but even within its own protocol, it has decoupled into 3 separate modules. So we're able to basically just become, in the transport layer, just a sub-protocol of the Waco network, where we can actually define the messages for WalletConnect to be broadcasted through the Waco network. And it's up to the developers to choose how they actually want to use this technology. For example, as a bootstrapping method, we want to run a relay server that will run a Waco node that allow applications to just broadcast the messages through our server. Additionally, wallets and applications can run their own relay server that can be broadcasted messages. But if you want to take it to another level, you can actually have the applications and wallets run the Waco nodes on the client side and still be compatible with the WalletConnect protocol, since they're being broadcast in the same network. So we're not just allowing a next level of flexibility for applications to define their sessions, but we're also allowing them to choose the level of decentralization that they want without losing the interoperability from their peers, where an application might just rely on our infrastructure that we host, and another wallet can run a client-side Waco node, and they're still going to be able to connect to each other.
Nice. Yeah, sounds good. So the V2 is sort of nearing completion of, I guess, the spec and your reference implementation. And then it's a case of many wallets implementing that. So what you're feeling about like timeline till we are in, a happy place with many wallets supporting V2 and maybe some multi-chain and Dapp supporting that?
So the focus in the last couple of months has been mostly about how we actually redesigned the idea of having a decoupling from the pairings and the sessions, introducing scopes of APIs and everything, where we're trying to not only be chain agnostic, but also multi-chain. We focused a lot on that because we thought that was like the most important part of WalletConnect, is how you can actually provide almost a firewall to your wallet. You want to open your wallet to the world, but you also want to have security over how much access you're giving to your wallet. Even if there is no private key access from the WalletConnect infrastructure or even on the client side, we want to make sure that users are not spammed with requests that they don't want. We wanted to really focus on developing a flexible protocol, but also a secure one. And now we're actually shifting our focus into the infrastructure side, where we're not just thinking about high performance on the server, but we also want to make sure that it is decentralized. So we're in alpha development, and within the next month, we hope to have full WACO compatibility so that we don't even require you to connect to our servers. If an application is using our servers and you're using a WACO network, we're going to be able to communicate between applications. And that's the focus for the next month. And we hope by the next quarter, we're able to publicly announce the beta and have the first apps and wallets actually run the WalletConnect protocol V2 and start using it on the WACO network. It's the last feature for beta.
Cool. Yeah, sounds good. One last point that I want to talk about, and then maybe see if my mobile to desktop demo still works, or desktop to mobile rather. You support Gnosis Safe or rather, Gnosis Safe supports WalletConnect, right? We had the Gnosis Safe team on Tech Tuesdays before, going into their architecture, and then it's the premier multisig wallet on Ethereum, maybe the only one currently, but still with a lot of value under management or stored in there, and they have this thing called Safe Apps, where protocols are able to implement some interface to get sort of an app within the Gnosis Safe user interface, and then you can directly interface with, say, Aave or other protocols from your Gnosis Safe multisig. But since Gnosis Safe supports WalletConnect, that would actually make it possible to use any Dapp with signing through the Gnosis Safe with the normal user interface using WalletConnect. So that seems like a a very sensible thing for people to do.
It's really the understanding of a multisig or a smart contract wallet is that it does have some particularities, and we do document this on our website as well, where you have to have an understanding that, number one, the accounts exposed are not signed by a key directly, so you shouldn't map those accounts to a key. And those are actually mapping to an actual smart contract wallet, which you can detect from the blockchain whether or not there is bytecode associated. And the second thing is that in order for you to verify a message from those wallets, you actually have to do a contract call to verify if the message was signed by one of the delegated keys that actually is authorized to sign for this wallet. And these are two simple things. Actually, there's a third one, but these are the two most important, I would say, to understand that when you're developing an application, you should also consider the smart contract wallet side. And I can understand the need that Gnosis Safe, the team, has put into developing these safe apps, because it allowed them to have a more ensuring a better user experience to take into account these nuances of smart contract wallets. And we've seen this even with Argent as well, where some applications didn't take into consideration these particular features of smart contract wallets, and then would have issues, and users would complain, this is the application fault, this is Argent's fault, or even this is WalletConnect fault. And it was
WalletConnect's fault because I chose WalletConnect. So yeah.
Exactly. It's actually it's very annoying, but it's also understandable that it's very complex, this ecosystem. So understanding whose fault is who, users will just complain to the first chat that they arrived.
Got it. Yeah, so that's actually a variant of that case that you described initially with the signing method, like it's supported or not. You can't really say you support WalletConnect v1 or not, because you don't have the definition yet of these methods are supported, and that extends to then smart contract wallets, which are or aren't supported. And in v2, you're better able to indicate like, okay, we support these methods, and you need to support them in those ways. And so it's basically a responsibility for the app developer side that they deal with smart contract wallets, and then they are able to support Argent directly, or Argent through WalletConnect, or Gnosis Safe through WalletConnect in a good way.
Yeah, exactly. Having these very clear communication channels where the interoperability can be made. We have to understand that previously we had client-server communication, and this was usually developed by the same team. So the team that was developing the client, the team developing with the server, was able to have this understanding of both ends of the communication. Here, we have completely no assumptions being made about who we are actually connecting to, which gave us a much higher level of interoperability and decentralization, but also introduced a lot of complexity. Oh, why is this not working if it says it's an Ethereum wallet? And this has to be built into the actual protocol to ensure a good user experience and actually allow applications to handle these use cases and prompt the user how to react.
Yeah. Cool. All right. I'm going to see if my my mobile interaction works when I show it. So we have on the left side, we have my desktop, Uniswap in the browser. On the right side, we have my mobile, which I hold in my hand, but you see the screen over there. I have 3 wallets on my mobile, and actually, interestingly, one is the MetaMask mobile wallet, which is not the MetaMask extension, but they now have a mobile version, which actually has a really nice WalletConnect integration. Like, because the level differs. In Trust Wallet, it seemed to be a bit rudimentary. It's like you see this screen and it's like not very clear, and on MetaMask it's quite clear. So I'll go for MetaMask right now. So okay, I'm on Uniswap. I wanna get some DAI. I want to get some ETH, I don't know. So I'm going to connect to my wallet. I'm going to choose WalletConnect. Here we go. Oh, I have a QR code. Okay, so on MetaMask, which has nice fingerprint authentication, one of the benefits that comes with mobile devices. And we're going to press this little button on the top right, and we're going to scan it. And there we go. And do I want to connect to this site? Well, yes, I do. I say connect. And the magic has worked because it sees my balance, it sees my my address. And now I can say, oh, no, I want over here. I can say I want some DAI. Please take that. Yes, there we go. I'd like DAI, please. Sounds good. So you get your regular desktop experience that that just works fine. You don't have any browser extensions here. And then we go for the swap, which then goes off to my mobile. And again, I get the notification. This looks crazy. I'm gonna pay about
90.
100 ETH to in fees. So let's leave that for now. I'm going to reject this, but as you can see, the flow works smoothly. So yeah, congrats on making that possible.
And I think most users don't even understand that there's benefits to WalletConnect that go beyond just this communication to mobile wallets. For example, if you own the device, you're likely to have the ability to actually install a browser extension and control the key that it's on that device. But for example, even if you're in a work device and you don't have admin privileges to actually install applications on your desktop, you can still use WalletConnect and sign securely from your phone. You can literally go to the library that doesn't even have the latest Windows installed and is probably compromised, and you can WalletConnect to that library computer and sign from your phone securely with the private key that you always have in your pocket. And desktop applications nowadays are not as secure as mobile applications. There was in the past more security concerns in terms of mobile applications, but applications now in 2021 are more sandboxed and secure than desktop applications.
Yeah, indeed. So that's very good to highlight. Like it goes beyond that, and it alters the security model somewhat in terms of like there was recently this case with a compromised MetaMask extension where somebody did use, they used a Ledger wallet and they used MetaMask on their desktop, but MetaMask was compromised. So actually the MetaMask showed something different than the what the Ledger actually signed. And in this case, you still need to be vigilant as a user to, when MetaMask or whatever, when your wallet on your mobile says, do you want to sign this? Sometimes you still have to sort of dissect, like, okay, there's a long string of characters here. Is that correct? But I agree, like it's quite a bit harder to compromise the app on someone's phone, especially if they use sane hygiene on the web on the mobile.
To have that level of compromise on a mobile application would require the user to have jailbreak on their iPhone or rooting their Android device, and that's something that on desktop application it's very easy to by mistake give that level of access. And in applications is actually, you have to literally break the way how the operating system works, because every single application is signed by the actual developer, which is curated at the App Store level. And it's much, much, much harder. And even in that case where the compromised transaction was sent to the Ledger, nowadays Ledger Live on the mobile app actually supports connecting with WalletConnect. So the user could actually connect with their Ledger Nano X, not Nano S, the X one, which supports Bluetooth, and connect to the mobile app, and then WalletConnect into the desktop to actually perform this action. Or on Android, we could actually use both Ledger and Trezor on Android through a WalletConnect app and actually connect remotely. So it gives you 3 levels of separation where you have desktop, mobile, and hardware.
Yeah, nice, very nice. Yeah, that aspect of hard to secure desktop apps. It's actually one of the reasons why development of Mist was ultimately abandoned. Like there was of course the downloading the whole blockchain thing, but Alex van der Sande posted a really good thread on like how they were playing whack-a-mole with security issues in Electron, and just wasn't possible. So this separation, like physical separation and operating system separation is it's really really good to see. Cool. All right. I'm looking at the time. We're close to the end of our 60 minutes. Live demo. It worked out. Yes. Both of them worked out.
We both did demos and it worked live.
Yeah. Wow. Must be a good day. All right. Yeah. So, Pedro, I want to thank you a lot for coming on. I learned a lot about WalletConnect, and I hope the audience did too. I want to mention Outlier Ventures, we run an accelerator called Basecamp for teams, companies, projects, early stage, building technologies, applications in Web3, in DeFi, in NFTs. Of course, they should all support WalletConnect. That's in first place. But if you or your friends or your family are building something great, then do give us a note. Next cohort starts in May 2021. And yeah. Thanks everyone for signing on today. And again, Pedro, thanks a lot.
Thanks for having me.
All right. Thank you. Cheers.
Bye.